Hello, Mr. Goulet. For my project, I chose to explain compositions of functions, transformations, and inverse functions. I chose these topics because they are all connected and need understanding of how functions interact and not just how to solve them. Now, to start off the lesson, I'm going to start with composition of functions. So composition means taking the output of one function and using it as the input of another function. So for example, if you have f of g x equals f g of x. Okay, so for example, we're going to have two functions. So f of x equals 3x minus 2 and g of x equals x plus 4. Okay, let's find f of g, that's a multiplied sign, of x. Okay, so what you would do is, let me move that real quick. What you would do is start plugging in the values. So this all citation basically means f, I need to erase this real quick, f of g of x, which is basically, we're going to leave f, and we already have g of x, which is this, x plus 4. So we're going to sub it in. And then we also have f of x, which is g of x. G of x acts as x in this case. So it doesn't matter what we plugged in, it's still f of x. So to fix this, we're going to have to plug in this 3x minus 2, which is going to be 3x plus 4 minus 2. And then all we got to do is just solve it. So it's going to be 3 times x is 3x plus 3 times 4 is 12 minus 2 is going to equal to 3x plus 10. Okay, let's try another one, which is g multiplied by f x. Okay, so we're going to write that, oh, I'm not bad. We're going to write that as g of f of x. So we're going to leave g like it was, and instead of f of x, we're going to plug in this 3x minus 2. So 3x minus 2. And then it still acts as an x in this case as well. Same thing as previous one. So what we do is, we would say, instead of g, we'll put just 3x minus 2 plus 4. Because g of x, it says x. So if we just leave it there. So 3x minus 2 plus 4 is going to equal to 3x plus 2. So f multiplied by g of x equals 3x plus 10, and g multiplied by f of x equals 3x plus 2. It's important to realize that these functions are not the same, and this shows that composition, basically the order matters in the composition function. It's also important to understand when you're working with compositions, it's important to consider domain and range. So the output of the inside function must be valid for the outside function. And if it's not, then the composition is undefined for these numbers that you got. Okay, so next point in my lesson will be transformations. So transformations describe how a function's graph changes position or shape. Basically, let me explain it to you. So let's start with parent function, which is f of x equals x squared. So this is a basic parabola you can find in the books, and its vertex is 0, 0, because there's absolutely nothing. So let's now consider function g of x equals x minus 2 squared plus 3. Okay, so this function has multiple transformations. So I don't know these crazy terms that are very mathematical, so I'm going to explain how I understand it. Okay, so if you see an x minus or plus something, so this in the parentheses is very important. When you see a minus sign in the parentheses, this usually means the parabola is going to shift to the right. If you see a plus sign in the parentheses, this usually means the parabola is going to move to the left. Now, outside the parentheses, if you see a plus sign outside of parentheses, this usually means that the parabola is going to go up. And then if you would see a minus sign, it will go down, respectively. So as we can see, it's x minus 2, right? So where would the function go? Right, just like I said. So this would go 2 units right. So we already, this basically, we move the vertex. So it will go 2 units up, and therefore if the original one was 0, this one will be at 2 because 0 plus 2 is 2. And now the other one is plus 3, which means it's going to move up 3. So 0 plus 3 is 3. So the vertex moves from 0, 0 to 2, 3. So I understand where kids might get it wrong sometimes, so let me admit that horizontal shifts can feel confusing. Although it says x minus 2 in the parentheses, the graph moves, again, let me emphasize this, to the right, not left. And this happens because the value inside of the parentheses has to equal 0. So the number you would add in the parentheses or subtract in the parentheses has to, like at the end, equal 0. So what number would you substitute for x to get 0? Well, 2, because 2 minus 2 is 0. So in addition to shifts, there are other important transformations, like vertical stretch right here. So as you see, this multiplies all y values by 2, making the graph narrower. There is also vertical compression, which makes the graph wider because the y values are reduced. There's also reflection over x-axis, which is going to be looking like this. This flips the graph upside down. And there is reflection over y-axis, which reflects the graph across y-axis. All these transformations allow us to understand how equations affect the shape and positions of graphs clearly. Another thing I want to point out in this video is inverse functions. So an inverse function reverses the effect of original function. So I wrote it off the script of the video, so it doesn't take much time. So for example, we have a function f of x equals 3x plus 6. Okay, so in order to reverse inverse, you need to do 3 steps. So 1, replace f of x with y. 2, swap x and y, and 3, solve for y. So let's do exactly that. So step 1 is replace f of x with y, which we did. Y equals 3x plus 6. The second step is swap x and y, which we did, which is x equals 3y plus 6. This should be pretty simple for now, because x, y. Now we're going to have to solve for y. So how would you solve for y? Well, first of all, you would need to subtract 6 from both sides, right? So x minus 6 equals 3y, and then we would just divide by 3. And this is the notation of how to write the inverse function. F of negative 1x equals x minus 6 divided by 3. So basically, inverse functions are reflections across the line. So y is equal to x, basically, in inverses. This means that every point, which can be a, b, on the original function becomes b, a on the inverse function. And so to sum up this lesson, I would love to say that these 3 concepts are all interconnected. So composition combines functions together. Transformations changes how functions look from original to another one, to the changed one. And inverses undo other functions. So understanding all of these 3 helps explain how functions interact among each other and why do they look how they look. So overall, these topics show that functions are not just equations, but systems that can be combined, changed, and reversed. By understanding these concepts, it becomes easy to analyze and predict how functions will behave. Thank you, Mr. Goulet, and have a good day.